Greetings! I am Dr. Luis Estevez, the founder of AIMM and the inventor of its technology. I'm going to talk to you today about how at AIMM we are bringing the functions of a water treatment processing plant into a simple filter. So first of all, if you're going to build the base of the future and embed installation resilience, you need clean water. There is no way around the fact that water is absolutely vital for any semblance of mission continuation. To avoid the unwanted weight, expense, and logistics efforts of bringing water to the base, using the local water is the most convenient route. Unfortunately, depending on the base, local water sources can be contaminated and unsafe to drink. Standard water treatment technologies are usually multi-component systems that require power, affecting base resiliency during cyber attacks and natural disasters that can cripple base power. Furthermore, natural disasters can further contaminate local water sources, exacerbating the problem. At AIMM, in order to address these issues, we have created a water filter technology that will take contaminated water and turn it into clean, good-tasting drinking water. The way this is done is by using a filter that is made up predominantly of a porous carbon material that has multiple levels of porosity. There are relatively large micron-scale pores that capture the larger organic materials present in the turbid water, that then have smaller nanometer-sized pores within the larger pore walls that capture smaller viruses and bacteria. These smaller pores also have silver nanoparticles embedded within their network of pores, which effectively kill viruses and bacteria. Additionally, there are sub-2 nanometer pores present throughout that capture taste and odor compounds, leaving the water actually tasting good instead of tasting like harsh chemicals. These multiple levels of vast porosity result in a highly permeable material with less irreversible fouling. This large porosity is present even with nanoparticles embedded within the pores. The innovative heart of the system is AIMM's Tunable Hierarchically Porous Carbon Materials Platform, or HPCs. This is worlds different than your standard activated carbon found in most water treatment devices, such as a Brita pitcher. Though our HPCs have high surface area, if not more, than typical activated carbon, it's also vastly more tunable as far as pore size, morphology, functional groups, and at the same time has massively more porosity compared to activated carbon. This colossal porosity allows for the loading and anchoring of biocidal nanoparticles while still maintaining high porosity, and it's demonstrably been proven to be less prone to irreversible fouling, which means higher water flux for longer. Thus, our HPC filters can provide the simple ease and use of a Brita system with the performance of a water treatment plant. Furthermore, this technology uses no exotic chemicals or hard-to-replicate procedures that are red flags to commercial scalability, and uses many standard and established commercial routes within the material synthesis process. This scalability extends further to the device size, which can range from large water containers to personal water treatment devices, giving our technology application flexibility. Additionally, due to the tunable nature of our HPC materials, it's not difficult to tailor them to specific water treatment applications, such as iron oxide nanoparticles embedded within the HPCs that can target arsenic removal. Now, doing all this is no trivial task, but at AIMM we have the prerequisite skill sets and experience in the field to accomplish it. I personally have spent over 10 years of my research career developing these HPC materials and their subsequent nanocomposites. My PhD work at Cornell University is based on my invention of these HPC materials, and right after graduating, I was offered a $1 million 3-year fellowship by the Department of Energy to further develop these HPC materials at Pacific Northwest National Laboratory. Since founding AIMM, we have been utilizing various collaborators from throughout years of research in the field, including Dr. Kenya Crossan, an expert in the field of water treatment, who is not only a strong collaborator, but a member of AIMM's advisory board. In addition to the strong team we have at AIMM, we have already shown that these HPCs can mitigate irreversible fouling when removing contaminants from actual wastewater from an actual wastewater treatment plant. And we are currently testing them for biocidal effectiveness with our collaborators at the University of Dayton. With our simple and effective solution, we at AIMM are SAM registered and poised for SBIR funding for prototyping and eventual commercialization. With that, I thank you for your time, and I'll be more than happy to answer any questions you may have.